We're here with Novtech, showing off a new 96 boards with the Altera FPGA.
Correct. This is the Altera Cyclone 5 SoC. It's an FPGA with a dual-core Cortex A9. And what this board does is mainly highlight the fact that there is an ARM processor in. That's why we chose the 96 board form factor, which intend for ARM. Most of the function running by the ARM. With that said, we're using the FPGA to implement the bridge into the HDMI. We're doing the MIPS inside the FPGA. We're adding additional serial port and I2C bus port and SPI port, all done inside the FPGA. We're running some security demos that we're using the FPGA hardware to do acceleration of key exchange and other protocols, all done on this tiny module.
So it's following the 96 board specifications.
Correct.
And it can boot from SD card.
It's booting from the SD card. It first boots the ARM, then the ARM program the FPGA with the configuration file that contain the FPGA design.
So is this the best way to get started to work with FPGA?
Exactly, because you actually don't do anything with the FPGA. It's being done for you. It allows you to understand what FPGA can do without the need to program them. It's all done here. If you are coming from a programming world, a software design, application design, you're getting a computing device that works like any other 96 board. And later on, when you're starting to feel comfortable with it, you can explore the FPGA, modify the design, implement different functions, not just the one that we placed there to meet the 96 board. All the signals that comes from the FPGA pins and go to the expansion port of the 96 board, you can do whatever you want with them. You can do any design, use them for any interface. That's the beauty of an FPGA, that each pin can be configured to a design that you place in the FPGA.
Usually, as far as I've seen before, people use FPGA to prototype something they want to implement SoC later.
It depends on there are two approaches to that. Why to use an FPGA? One is, as you said, to prototype something before the big investment of creating a gate array or ASIC. You're using an FPGA to prove that your IP works and that it performs to the level that you want. I wouldn't say that this board is the most optimized board for that purpose. There are a lot of other development boards, but it's a starting point to understand FPGA. If you have no idea about FPGA, this is a good board to start with. Other reason to use FPGAs is when you're doing a solution that there is no industry standard protocol, or the solution keep evolving. So you don't want to invest in doing an ASIC that by the time the ASIC is ready, those protocols are already gone because there are new ones. So that's another reason to use FPGA. And of course, when you don't have the quantity, if you need to create a very unique algorithm and you need 500 system or 1,000 system or even 10,000 system, probably the investment in creating your own ASIC cannot be justified. So there are many reasons to do FPGA. They are very flexible and allow you to implement very quickly algorithm and verify that they perform and do what you think that you can achieve with them.
So it's an SoC, right? So what does ARM do in SoC? What does FPGA is? ARM is just a small part of it, but what role does it take?
SoC, the acronym System on Chip, refers to the fact that we do not do that, but manufacturer integrates many peripherals into a single die. So usually you will have the actual processor, and you will have the memory controller, and then you have display controller and serial protocols like SPI and I2C and USB, and you will have an acceleration engine for security. That's what SoC stands for. With the Cyclone 5 SoC, in addition to all those things that I mentioned now, we have the FPGA fabric, where we can do design of hardware, we can do parallel computing, we can do very fast algorithm implementation that cannot be achieved with a regular processor.
FPGAs are being used like in self-driving cars and stuff like that, right?
In where?
In the car.
FPGA are being used everywhere. Again, the idea behind FPGA is FPGA started by integrating logic cell. If in the past you had to buy a chip that is an array of NOR gates, another chip is an array of AND gates, and you will play them on a board, the initial CPLD and later on FPGA basically allow you to implement them in a single chip. But that evolved much since then, to the point that you can put computing unit, you have a lot of memory inside FPGA, you have memory block, you have DSP blocks. Basically you can, as I said, design. There is no limit to what you can design with an FPGA.
Is this one of the most popular FPGAs from Altera? Cyclone 5.
Cyclone 5 is the latest in the what called the low end. You have the mid-range, which is the ARIA families, and then you have the high-end family, which are Virtex.
So this is a small one. Here you have a big one. You do.
You know, actually, it's confusing. Although this is a larger package, from the FPGA, this is exactly the same resources. The only difference between this Cyclone 5 SoC and that Cyclone 5 SoC is the package size. There are more IOs.
Okay.
In this one, if here in this package you get 288 signals from the FPGA. On the FPGA that we have on the 96 board, you get only 66 signals. But from FPGA internal resources, the parts are identical.
So what is this? You're showing different solutions here. What is this one?
Correct. This is our IoT Octopus. This is basically an high-end IoT point. What we have here is a device from Analog Devices. It's a 24-bit Delta Sigma, sorry, keep making a mistake. It's a Sigma Delta A to D, 24-bit, 8-channel simultaneously sampled. So there is a lot of data flowing in, and all this data is being collected by the FPGA. The FPGA can arrange the data, can manipulate the data, can do calculation on the data, analytics on the data, and then this data can be touched by the ARM processor, and later on, this data can be transmitted over one of the 3 Ethernet ports that we have here to the next level. In addition, we have a GPS that allow us to synchronize boards all over the world based on a GPS 1 PPS signal. The initial target for this board, for the IoT Octopus, was the smart grid, where you're monitoring the grid, and that's why the synchronization was so important. But basically what we have here is an high-end data collection system that work on any electromechanical equipment, if it's a pump, if it's a motor, engine, turbine, battery charger, a variety of sensors, analog sensors that are very, very sensitive, and you want to get good resolution. All of that can be achieved with this board.
And you have even more solutions right here. This is another, what is this one?
I will just show you this one first. What we did here, this is an emulator. You can show it here, where instead, before you connecting to your actual sensor or equipment, we provide you with a simulator. Each channel, you can create its own waveform. So that allow you to do a development of all your solution before you need to connect to an actual hardware. And of course it can work on the medical equipment as well. This board here, this is our NetLip. And I think that the name of the board says everything. It's an Industry 4.0 IoT, industrial IoT, multi-protocol, Ethernet ports aggregator platform. We can implement here a variety of Ethernet protocol. There is no one standard in industrial Ethernet. So you can put different protocol, you can translate between them. That's what this board does. Those 2 boards are production ready, so you can do production.
How much is the 96 board? The Chameleon96 is available?
It's a what?
Where can people buy this one?
They need to go to arrow.com. The board will be, the distributor, that board will be available within 6 weeks from now. So if you go I would say end of April, Aero should have stock on this board.
And how much?
End of April.
How much is the price?
I am not sure, but it's possibly around $100 range.
So it's very affordable way to get it.
Affordable, yeah.
And you also do one with the IMX over here?
This is the IMX7. The name of this board is the Meerkat. Again, as you can see, it's the same form factor. All the connectors are the same. This is the low-speed expansion port, the high-speed expansion port, SD card, HDMI, micro USB, 2 USB port, and the Wi-Fi Bluetooth. This is all what the 96 board calls for. And that's the beauty, that you can place all the mezzanine cards that are for 96 board will work regardless what is the process or the driver. And we at Novtech developed those two boards, and they are both being sold to introduced into the market by Aero.
And here, the booth, you have your partner at GEM, right? Can you introduce what do they do?
I think the best is to let them say what they do,
okay.
But I can just tell that we did the platform, which means the hardware design and BSP board support package for the Linux. GEM took it to the next level and do the connectivity to the cloud and make the data available in a graphical form for a user. And I think that Gal and Ramesh will take it from here.
Hi. Hey, hello. So who are you?
Hi, this is Dharmesh and I'm Gal. Nice to meet you. So GEM is a company that basically brings together what's called the Industry 4.0 or Automation 4.0, where it's a IoT is a word, is a buzz. Now bringing it in all the way through to people. Means a lot, meaning that for them to create a complete solution for automation, for control, for analytics is tough. So what GEM does, we provide a complete solution that allows the customer, for example, like we did with Novtech.
Like on here?
Yes. So what we're seeing here, we have a technology called GEM Inside, which it's basically a set of agents that can be customized. And that's one of our benefits. We can customize ourselves to your design, to our customer. They don't need to customize to us. So here we're bringing in 8 channels of A2Ds, each one 32 kilohertz, meaning that basically there is over 250,000 samples per second that we are doing analytics on it in real time.
Which board is it running on?
This one. So it's
going all through the FPGA.
Yes.
And you're doing the software in there?
Yes, we're doing the software in there and doing a hybrid analytics both at the edge and in the cloud. Now we're solving customers' security constraints all the way through, meaning there is security that is running on the board, and our solution is both public cloud or private cloud, which is unlike anyone else.
So it's possible to do security with an FPGA. Is it a good solution for that?
Yes, this is a good solution for that.
Is hardware security?
Yes, so there is a combination of hardware security that Novtech implemented with software security that we implement with the networking stacks that we provide, yes.
And the software you're doing, can you also get it to run on here?
Yes, it's extremely light and flexible. It can run on 32, 16-bit processors and different types of processors.
Is it based on Linux?
It can run all across. It can run embedded without operating system, Linux, Microsoft, Android, Ubuntu, Angstrom, and so forth and so on.
Cool. So you expect that with the Chameleon96 there will be maybe Altera is very excited about this. There's going to be a big community join making interesting things with that, right?
I hope so.
All right. Cool. So thanks a lot. Thanks for the demonstration.
I am, but that's okay.
Yeah, I forgot. I'll write it down.
You have your own card?